this class on the topic collisions. When we talk about collisions, it is primarily the two bodies, they may physically come in contact with each other, or the velocity of one body may be affected because of the other body. So collisions, there may be physical contact, there may not be physical contact. So when we speak about collisions, collisions may be head-on or direct collisions. Let's say a body is coming from here, the other body is head-on coming from here, both the bodies collide. So this is what we call as direct collision. This is direct, and this is also called head-on collision. And this is also one-dimensional collision. It may be, let's say, one body is going in this direction, the other body with a greater velocity hits it from the back, and both the bodies, they are just moving along the x-axis. If we take this as x-axis, this is y-axis, and both the bodies, they keep on moving along the one axis only. That is what we call as collision in one dimension. There could be case, let's say, a body is coming from here and the other body is coming from here. Let's say this is x and y axis. This is body A coming here with some velocity v1, this is coming with velocity 2, or let's call it as va and vb. They come over here, collide, and then they move. So this is case of an indirect collision or a collision in two dimensions. It is not necessary that these two bodies, they should be coming at 90-degree angle. It may be one body is coming like going like this and the other body is going like this. They strike over here, somewhere over here, and then they move in this plane. This is case of a collision in two dimensions. The other differentiation of collision or the categorization of collision is on the basis of whether the kinetic energy is conserved during these collisions or not. When the kinetic energy is conserved, let's say when the two bodies collide, they obviously have some kinetic energy. One may be at rest, but the other has to be moving. Or when both the bodies, they are moving. When we say that is the initial kinetic energy, that is kinetic energy before the collision is equal to kinetic energy after the collision, then we say this is elastic collision. That is kinetic energies of the system, they are conserved. That is whatsoever the colliding bodies, they have the kinetic energy before the collision, the same kinetic energy they have after the collision. When we say same kinetic energy, it is we are talking about the total kinetic energy of the system. Kinetic energy of, suppose there are two bodies, they collide with each other. So kinetic energy of this body, it may be changing. Suppose this loses some kinetic energy. So conservation of kinetic energy over here, that's what we say is in elastic collision. If someone is losing kinetic energy, the other one should be gaining kinetic energy, so that the total kinetic energy of the system, that is conserved. It is not individual. The other case is when the kinetic energy of the system is not conserved. Initially, the colliding particles or colliding bodies, they have some kinetic energy, but after the collision, because some energy it is going to be lost as sound energy, heat energy, etc. So the kinetic energy after the collisions is generally lesser than the kinetic energy before the collisions, and such collisions where the kinetic energy is not conserved, we say that is inelastic collisions. So we have two categorizations. One is elastic collision, the other is inelastic collisions. In elastic collisions, the kinetic energy of the system is conserved, and in inelastic collisions, the kinetic energy of the system is not conserved. When we talk about the inelastic collisions, there is one more special case where the two bodies collide together and they move as one body. It is like a wooden block is there, a bullet comes, gets embedded into it, and both the block and the bullet system, they move with a common velocity. So this is also a case of inelastic collision, and in such an inelastic collision where both the bodies, they move together with a common velocity, this is called perfectly inelastic collision or perfectly plastic collision. So when we say perfectly inelastic collision or perfectly plastic collision, it means after the collision, the bodies, they will be moving together with a common velocity. So what we have is, we have direct collisions or what you call as indirect, and this is also called oblique collisions. This is one dimension collisions and this is two dimension collisions we are talking about. And then on the basis of kinetic energy, when we talk about kinetic energy, we have, if it is conserved, we say elastic collisions. Kinetic energy, we say it is conserved, that is before collision, that is kinetic energy before collision is equal to kinetic energy after collision, not of the individual particles but of system. And in elastic collision, kinetic energy is not conserved. Obviously, that is after the collision the kinetic energy will be lesser than the kinetic energy before the collisions, because some energy is lost as a sound energy, heat energy, doing working of friction, etc. These things may be happening. So in elastic collision, and in inelastic collision we have one interesting case, that is what you call as perfectly inelastic. Either you say perfectly inelastic or you say perfectly plastic. It's one and same thing. One and same thing. Here what happens is, after collisions, both bodies, both or whatsoever number of bodies you have, after collision both bodies move together as one body. That is, they have a common velocity, they move together as one body. So this is generally how the collisions they are categorized. Whenever there is a case of collision or explosion, the first thing that should occur to our mind is conservation of linear momentum. Why? Reason being, Newton's second law is F resultant force is equal to rate of change of linear momentum. This is what we have done it. So if it goes over here, this makes linear impulse. This is linear impulse. What you call as linear impulse, we have done it in laws of motion, and it is Newton's second is the unit. So linear impulse is equal to change of momentum. When we talk the collisions or explosions, then huge force, there is a massive change in the velocities of bodies, whereas this time is very, very small, almost equal to 0. So when it is 0, almost equal to 0, so this is almost equal to the whole thing almost equal to 0. So it means dP, that is which stands for change in momentum, that is equal to 0. So when change of momentum is equal to 0, it means momentum before collision is equal to momentum after collision. So whenever there is a case of collision or explosion, the first thing is you have to think about conservation of linear momentum. Please do not jump to conservation of kinetic energy. There may be a case of conservation of kinetic energy, it may not be a case of conservation of kinetic energy. If it is given, that is the collision is perfectly elastic, then there is going to be a case of conservation momentum also, and there is going to be a case of conservation of kinetic energy also. But if it is given, that is the collision is inelastic, then it is only conservation of linear momentum, and you cannot use conservation of kinetic energy.